Hello students, today we shall discuss triple integration and some of its applications. If we have given function f of x, then using integration over a to b f of x dx, we can find area of the region. If you have given the function f of xy, then we can find volume using the double integration corresponding to the bounded region R. So from f of x to its generalization f of xy. Now let us generalize it to f of xyz. So we have the function f of xyz and we have given a solid S, right? Then here we have area, here we have volume, and here this is the quantity which is something in 4-dimensional, right? Here what is dA? We can represent dA by either dx dy or dy dx. So likewise here ds we can represent by either dx dy dz or dx dz dy or dy dx dz, right? Or any combination of dx dy and dz. Now suppose I assume that this function f of x is 1, f of xy is 1, or f of xy z is 1, then what does it mean? What does this integral represent? It represents the length of an interval, the interval from a to b. So this is single dimensional geometry. In double dimension geometry, that is 2-dimension geometry, what do we have? We have area of the region R. So here in single dimension we have only line, so length of the interval. In 2-dimension we have xy plane, so the portion of the xy plane we are finding the area. And likewise, if I assume f of xyz equal to 1, right, then in 3-dimension geometry, suppose I have given any solid S, then what is the volume? So here we have two kind of examples. One is if we have given any function f of xyz, then what is the triple integration? That is the quantity from the 4-dimension. If I assume f of xyz equal to 1, then what is the volume of solid? So let us start with some simple examples. Here our first exercise is evaluate integration over -1 to 1, 0 to 1, 2 to 4 xyz dz dy dx. Now first we understand out of these three limits, which one is the limit of z, which one is the limit of y, and which one is the limit of x, and then we continue the integration. Now see, xyz dz dy dx. So most inner limit is z, so these are the limits of z. The middle one is y, so the middle limit is of y, and outer limit of x, so outer limit of x. I always mention this representation, that which is the limit of x, which one is for y, and which one is for x. So here these are for z, z is equal to 2 to 4. The middle one is for y, y is equal to 0 to 1, and the outer limit x equal to -1 to 1, because inner is z, middle is y, and outer is x. Now first what I do, I integrate the quantity with respect to z. When I integrate with respect to z, x and y are assumed as constant. Then what is the integration of z? Z square by 2. And so this becomes integration x equal to -1 to 1, integration y is equal to 0 to 1, x and y are constants, and the integration of z is z square divided by 2, with the limit z is equal to 2 to z is equal to 4 dy dx. Integration x is equal to -1 to 1, integration y is equal to 0 to 1, x into y. When I substitute z is equal to 4, 4 square as 16 divided by 2 is 8, minus When z is equal to 2, 2 square is 4. 4 divided by 2 is 2. So 8 minus 2 dy dx, which is equal to integration x is equal to minus 1 to 1. Now see, 8 minus 2 is 6, which is constant. I take it outside. Now I have to integrate this quantity xy with respect to y. X is constant. What is the integration of y? Y square by 2. So this is x y square by 2 with the limit y is equal to 0 to 1 dx. And so this is equal to 6 into, when I substitute the values of y, upper limit is 1. So 1 square is 1 by 2. And when y equal to 0, everything is 0. So 1 by 2, I take it outside. Clear? Then integration x is equal to minus 1 to 1 x into dx. 6 divided by 2 is 3 into, what is the integration of x with respect to x? X square divided by 2 from x is equal to minus 1 to 1. Now this is equal to, I am writing 3 divided by 2. When x is equal to 1, x square is 1, minus sign for lower limit. When x is equal to minus 1 square is plus 1. So again this is 1. One minus 1 is 0. So the answer of this integration is 0. In this example, only the important thing is which integral limits are for z, y and x. Then how do we integrate the quantity with respect to z, with respect to y and with respect to x. Now let us move for the next example. So here what is happening? I have given dy, dx and dz. So inner limit of y equal to x minus z to y equal to x plus z, that I am mentioning here. Y is equal to x minus z to y equal to x plus z. The middle one is for x, so x is equal to 0 to x is equal to z. And the outer limit of z, so z is equal to minus 1 to z is equal to 1. Clear? Now with respect to which variable first I need to integrate? The most inner one is the limit of y is equal to x minus z to x plus z. So first I integrate with respect to y. When do we integrate with respect to y? The variables x and z are treated as constant. So this is x equal to z. I integrate the quantity with respect to y. So x has integration x into y has integration with respect to y is y square by 2, z has integration z into y with respect to y. Don't make any mistake while you are integrating with respect to either x or y or z, because here you are dealing with 3 different variables. Make sure dx and dz remains as it is. So this is equal to integration z equal to minus 1 to 1, integration x is equal to 0 to z, x into. Now we are substituting the values of y. Upper limit, what is y? X plus z. So this is x into x plus z plus x plus z whole square divided by 2 plus z into x plus z. This is the upper limit. Now minus sign for lower limit. Keep in mind there are more than one terms. So please write minus sign and all this quantity into the separate curly bracket. What is y now? The lower limit is x minus z. So I am writing x into x minus z plus x minus z whole square divided by 2 plus z into x minus z. Whole dx dz. I have just expanded this thing. X into x is x square, x into z is xz, then this is a plus b whole square, s square plus 2ab plus b square, divide by 2, which gives me x square by 2 plus 2xz by 2, which is xz plus z square divided by 2. Then this is xz plus z square, which I have written here. Then minus sign and all these quantities. So minus of x square, then this is minus xz, minus minus plus, then this is x square by 2 with minus sign, minus 2xz divided by 2 is actually minus xz. With this minus sign it is plus xz, plus z square by 2 with minus sign it is minus z square by 2. Then this is xz with minus sign and minus z square with minus sign, which will be plus z square. And after that I collect xz, xz, xz and xz, which is 4 times xz, and z square and z square, which is 2 times z square. Now we integrate this quantity with respect to x and then finally with respect to z. So what is the integration of this with respect to x? Equal to integration z is equal to minus 1 to 1. The integration of x is x square by 2. So this is 2x square, z remains constant, plus 2 z square remain constant, and integration is x with x is equal to 0 to x is equal to z dz. And so this is equal to z is equal to minus 1 to 1. Now when do we substitute x equal to z? This is 2x square into z equal. Now when we substitute x equal to z, this is 2z square into z is 2z cube, x equal to z. So this is again 2z into z square is 2z cube. When x equal to 0, both the term are 0, and integration with respect to z. So this is equal to 4z cube. 4 is constant outside. Z cube has integration with respect to z is z raised to 4 by 4 with the value z is equal to minus 1 and z is equal to 1. Now when we substitute z equal to 1, this is 1 by 4. When we substitute minus 1 raised to 4 is again plus 1. In between we have minus sign of the lower limit. So this quantity becomes 0, and therefore the final answer is 4 into 0, which is 0. I repeat again, in this example, the inner limit of y, outer limit, middle limit of x, and outer limit of z. So first we integrate the quantity with respect to y, substituted these limits. Then we integrate with respect to x, substitute the limit, and then we integrate with respect to z. When do we integrate with respect to y and substitute the limit? After that step, there is no y, right? Then when we integrate with respect to x and substitute its value, then again there is no x. So in this way, step by step, we remove the variables y, then variable x, and finally the variable z, and the answer is always the constant quantity. The exercise is integration over 0 to 1, integration over 0 to under root 1 minus x square, integration over 0 to under root 1 minus x square minus y square, xyz, dz, dy, dx. So the inner limit of z, that means this is z is equal to 0 to z is equal to under root 1 minus x square minus y square. The middle limit of y, so y is equal to 0 to y is equal to under root 1 minus x square, and outer limit of x, which are always constant, so x is equal to 0 to x is equal to 1. What we have to do? First we integrate with respect to z, then y, and then x. So what is the integration of x, y, z with respect to z? Integration x is equal to 0 to 1, integration y equal to 0 to under root 1 minus x square, xy, integration of z with respect to z is z square by 2 with the limit of z. So z is equal to 0 to z is equal to under root 1 minus x square minus y square dy dx, which is equal to integration x equal to 0 to 1, y equal to 0 to under root 1 minus x square 1 upon 2 xy into now z square. What is z? Under root 1 minus x square minus y square. Its square is 1 minus x square minus y square. Minus sign for the lower limit. Now z equal to 0. So it is 0 dy dx. And so this is equal to integration x equal to 0 to 1, integration y equal to 0 to under root 1 minus x square. I am writing 1 upon 2 outside. So this is 1 upon 2. Now xy into 1, which is xy, minus xy into x square is x cube y, minus xy into y square is xy cube dy dx. Now what I do? I integrate this quantity with respect to y. So this is equal to 1 upon 2 integration x equal to 0 to 1. Now integration of the quantity with respect to y. So x y square by 2 minus x cube, y has integration y square by 2 minus x, y cube has integration y raised to 4 by 4 with the limit of y equal to 0 to under root 1 minus x square dx. This is equal to 1 upon 2 integration x equal to 0 to 1. When we substitute y equal to under root 1 minus x square, right, then what is y square? Y square is 1 minus x square. So this is x into 1 minus x square by 2 minus x cube, y square is 1 minus x square divided by 2 minus x into, what is y raised to 4? Y square is 1 minus x square. So y raised to 4 is 1 minus x square whole square. Don't make mistake here. Don't write 1 minus x square raised to 4 hurriedly. Divide by 4 dx. Let us expand the large quantity. So x into 1, which is x, so x by 2, x into minus x square, so minus x cube by 2. Now this is minus sign, so minus x cube by 2, then minus minus plus, x cube into x square is x raised to 5 divided by 2, so which is plus x raised to 5 divided by 2. Now minus x into 1 minus x square whole square is 1 minus 2x square plus x raised to 4. So 1 minus 2x plus x raised to 4 whole multiplied by minus x divided by 4, which gives me minus x by 4 plus x raised to 3 divided by 2 minus x raised to 5 divided by 4. Now I can cancel out plus x cube by 2 minus x cube by 2, and so finally x by 2 minus x by 4 is x divided by 4, then minus x cube by 2, and then x raised to 5 by 2 minus x raised to 5 by 4 is plus x raised to 5 divided by 4 dx. Now if you take 4 LCM, then this is 1 upon 8. Then integration x equal to 0 to 1. This is x. This will become minus 2x cube, and this will be x raised to 5 dx. So this is equal to 1 upon 8 into, what is the integration of x? X square by 2 minus integration of x cube is x raised to 4 by 4. So 2 and 2 will be cancelled out. It becomes x raised to 4 by 2, and here the integration is x raised to 6. divided by 6 from the limit x equal to 0 to x equal to 1. So this is equal to, now see, when you substitute x equal to 1, this will be 1 by 2 and minus 1 by 2. So 1 by 2 minus 1 by 2 will be cancelled out. Only the remaining quantity is 1 upon 6. So 1 upon 8 into 1 upon 6 is 1 upon 48.